All right, let's just dive right in. Kubernetes is absolutely fantastic for stateless applications. But what happens when your app actually needs to remember stuff, like a database? And that right there is the huge challenge we're going to tackle. How to run stateful applications on a platform that was basically designed for things to be forgotten. So let's get right to the heart of it with the most important question you could ask. Imagine your database pod is humming along. Everything's working great, and then poof, for whatever reason, that pod dies. What happens to all of that precious data it was holding on to? Well, here's the default and kind of scary reality. It's just gone, vanished, forever. See, the storage that was attached to that pod was ephemeral, which is just a fancy way of saying it only existed as long as the pod did. When the pod disappears, so does your data. And that's the fundamental problem we have to solve. And this really breaks it down perfectly. On the left, you've got the problem. By default, the data's life is tied directly to the pod's life. On the right, you've got the solution. We break that link using persistent storage. The way we do this is with something called a persistent volume claim, or PVC for short. It makes the data's life totally independent from the pods. So that brings us to our first really big idea here. We're going to make our data persistent, and our number one tool to get that done is the super powerful persistent volume claim. So what is a PVC, really? The best way to think about it is like a claim ticket at a code check. Your pod shows up with this ticket, and Kubernetes makes sure it gets the exact same piece of storage back every single time. It doesn't matter if the pod gets recreated on a totally different computer. With that ticket, it always gets its data back. That's how we guarantee our data sticks around. Okay, a PVC totally solves the problem for one single pod, and that's a huge step, for sure. But what happens when things get more complicated? What if you're running, say, a 3-node database cluster, where every single pod needs its own unique, persistent data? How do you manage that? Well, that's where our next tool comes in. This is where we need to introduce the stateful set. It's the Kubernetes object built specifically for managing groups of stateful applications, just like that database cluster. And this is where you see the huge difference. A normal deployment, well, it gives pods these random names, and they usually share one storage volume. A stateful set is different. It gives each pod a stable, predictable name, like Mongo 0, then Mongo 1, and so on. And crucially, its own unique persistent volume claim. So every pod gets its own private persistent data store. It's a total game changer. So why bother? Well, you use a stateful set for a few critical reasons. First, those stable network names are vital for databases to find each other in a cluster. Second, you get ordered deployments, meaning Mongo 0 always starts up before Mongo 1. And of course, you get that stable, unique storage for each pod. For things like cluster databases, this isn't just a nice-to-have, it's absolutely essential. Awesome. So our app is running, its state is persistent, but our job isn't done, not even close. Now we have to put on our operator hats and think about the long run. How do we protect this data? How do we move it around or back it up? Okay, let's say you need to upgrade your storage, maybe move from an older, slower SSD to a new, faster one. Now, you can't just edit the existing PVC. Instead, it's a pretty clean 3-step dance. First, you create a brand new PVC that points to your new, better storage type. Second, you use a little utility pod to copy all the data from the old volume to the new one. And third, you just update your application to point to the new volume. Done. It's a really manageable process. And the best part? You don't have to do all this by hand. For anything complex, or if you want a really solid strategy, the best practice is to use dedicated tools. Things like Valero or Kasten K10 are literally built to handle these kinds of operations automatically, and more importantly, safely across your whole cluster. Now, beyond just moving data around, we need backups, right? The native Kubernetes way to handle this is with something called a volume snapshot. It does exactly what it sounds like. It takes a perfect point-in-time snapshot of your volume's data. This is your get-out-of-jail-free card for data corruption, accidental deletions, pretty much any disaster you can think of. And if you're gonna do snapshots, here are the pro tips. First, you've gotta automate it. Don't rely on someone remembering to do it. Second, for real disaster recovery, store those snapshots in a completely different geographical region. Third, set up retention policies so you're not paying for ancient snapshots forever. And listen, this last one is so important. A backup you haven't tested is not a backup. You have to test your restores. All right, one last really common challenge. Picture this. Your application is a huge success, it's growing like crazy, and it's starting to run out of disk space. How do you give it more storage without taking the whole thing offline for a maintenance window? So let's say your volume started at 20 gigabytes, but your application is growing and it now needs 50. This is the cool part. With modern Kubernetes and cloud storage, you can actually expand that volume from 20 to 50 gigs on the fly while the application is still running. That's right, no downtime required. You just edit the PVC definition, apply the change, and you're done. Okay, so there are a couple of catches here. It's not totally magic. First, your storage class has to be configured to allow expansion. Second, your cloud provider's storage driver needs to support it, which thankfully most of the major ones do these days. And the real best practice? Use monitoring tools like Prometheus to tell you when you're getting low on space so you can expand proactively, not reactively when everything is on fire. So let's step back and look at the whole toolkit we've just built. What we've covered here is basically your complete starter pack for managing any stateful workload you can throw at Kubernetes. This table really wraps it all up nicely. If you just need your data to stick around after a restart, that's a job for a PVC. Simple. Need to move to a new storage backend? You'll create a new PVC and copy the data. Managing a database cluster? That's what stateful sets are for. Need to protect your data? You'll use volume snapshots. And for when your application grows, you use dynamic scaling. Every common scenario has a specific tool for the job. So let's end with this one final thought. Following all these patterns, you've made your data persistent, which is a massive win. But here's the next question you've got to ask yourself. Have you made it truly resilient? What happens if an entire region goes down? That's the next step on the journey.